So, and similarly to our last exercise, we're just calling alerter later. So the set timeout is JavaScript calling it later in 1 second. And here we are deciding to call it later explicitly. Thumbs? It's okay if you have a middle thumb. Well, most people don't understand this. Thumbs online? Any questions? What is most confusing about this idea right now?
I get the part where you're storing closure alert in the func store and that becomes a function, and so there's like that permanence with X.
Mm-hmm.
Because you're not really calling anything, you know what I mean?
Mm-hmm.
But I still don't understand why is that called closure, or what's the closure in it? Or
Yeah, so this part is the closure. The closure is the function that you can call later. And it's called a closure because it has reference to a variable from the environment, from its parent environment. So this is a closure. Func store is a closure because it holds reference to X. So X is initialized and manipulated in a different scope. So we could do a bunch of stuff to X. In this case, we're just adding to it, but you can imagine that could do a lot of different things. And since func store holds reference to the environment, it's a closure.
If you just wrap all of that code in an anonymous function with no name, is that all that code would be in a closure is a function? Is that true, I guess?
I don't know. I'm not sure. So you're saying if I wrapped all of this in?
Yeah, because the way I'm seeing it is you can either assign a function to a variable, if you took off the line where it says var func store equals closure alert, if you took the parentheses off, you would just be reassigning the function to func store, and it wouldn't be a closure. But if you leave the parentheses on, it is a closure. So really it's just a function.
It's because the key here about why we're calling it is because it's storing a function. So this closure alert is returning a function.
So what's the difference between var func store equals closure alert without parentheses and that line?
Sure, that's a great question. So let's do that. So we can first just, oops. So there's our closure alert, right? If we just type out closure alert, it's just a function that's not called. So it just prints out the function body. So if we can call it func store. This is where you store the func. And we just assign that to closure alert like this. It's just going to assign the function body of closure alert. So now if we look at func store with a K, it's just a function body. And we could call it, what is this going to return?
A new alerter function?
Mm-hmm. So it would return something that looks like this, right? Right? Whoops. And what we want is we want to be able to call the alerter function from func store. So what we could do so this is my alert func equals closure alert. And so now my alert func is actually that function, which then you can call and it will actually alert. Versus, what did I call it? Func store. If I call it, It's just returning that function, and we'd have to do something like this for it to work, and that's just weird. And it wouldn't work if we wanted to do it twice. It would always just alert once. So by storing that alerter function in a variable and being able to call it more than once, we can continue to have access to that parent scope, to this variable x.
So it's not like you have to have a global variable, or, you know what I mean? So I'm trying to think of kind of like real world application, very simple real world application for this, as opposed to saying, well, I'm going to set x to be a global variable in my window and then messing with that. It's a compact way to kind of still have that functionality, but keeping it local.
Yeah, totally. So if we wanted to, let's see. So another example here, unless we have questions on this example. Yeah.
The alert plus x, why does that increment x?
That's just a shorthand. You can think of it saying x.
The alert, that gives you an alert box, right?
Yeah, it would be in the alert. So it's going to increment it, and then it will alert it, and that creates an alert box. That's just a browser feature.
And after that, if you get a console log on X, you would see a V1?
Yeah, right here?
Yes.
Yeah.
And so when you're saving it down below, let's see if I understand this, you're saving not only the function, but all the values in the function after the function ran.
Yeah, so you're saving all the values within the function, and also all the values it has access to in the scope. So also it has access to this parent scope. So it has access to its own scope as well as the previous scope. Which is the same as how we were doing it here, right? We just alert x, and this alerter function had access to x up here. And then, for this example, we have the set timeout. Even though alerter is being called later, in 1 second, it still holds access to its parent scope. So the only difference for this one is that we're just returning it. And then once we return it, then we can call it later. So for the set timeout example, JavaScript's calling it later. In this example, we're calling it later. We're calling it later here. One more question.
Can you do some of the whys? Why?
Why you would do this?
What's in it for the programmer?
What's in it for the programmer? There's a lot.
Just give me the top three.
The top three?
Three
Well, I'm
uses.
going to go through different use cases next. But I mean, the biggest thing is privacy, right? Is that you can make like an interface into, when we get into the module pattern, I'll show you how you can you can make classes, basically classes in JavaScript using Clojure, and you can limit how your program can interface with certain values. So once it's private, the only thing that can access it, once you have this Clojure scope here, the only thing that can access and manipulate that data up here is this function. And so you can really limit on how you can manipulate whatever variables you have in the Clojure. So that's the biggest thing. But there's a lot of different use cases for it.
There was one more question here.
Sure.
The func store calls alerter. She was asking if that's correct.
Yes.
Okay. It doesn't call Clojure alert.
No, it does not call Clojure alert, because what happens is once we call Clojure alert, whatever that function returns is what's actually being stored in the variable. It's not actually, when we refer to func store later, it's not looking up and calling Clojure alert again. closure alert at this point is being called once. And then when we reference it down here, it's just referencing whatever this had returned from the beginning. So when we call it again, it's not recalling closure alert. Because if that was the case, then we'd be resetting x to 0 every time. So here's an example of how we could use closure. So maybe we have this add function, and we wanted to just like make a generic add function called like add 5 equals add 5. And now we have this add 5 function that we can call later with another number. Let's do a smaller number. And that would give us 7. And let's walk through exactly how this is working. Let's play the game. Where did we leave off for our game? Did we leave off? Grace, you went. Joe went. I think it was your turn. Let's walk through how this is running in our browser.
Well, you set the function add as a variable.
Mm-hmm.
You skip down.
To the bottom. Cool. Perfect. Okay.
Variable add 5 is add.
Mm-hmm. So we call the add function, and then who's that back there? William?
So you call that function that the variable add is pointing to, so the value of 5 goes into the num.
Mm-hmm. So then we get into the function body. Num is now 5. And then Andy?
So then we're creating a local variable called num1, setting it to the parameter 5.
Mm-hmm.
And
Kevin?
then new function add to num1.
Mm-hmm.
It's defined.
And then you return that function without running it.
Yeah. So we skip over the function body here. This never is run. Then we just return add to num1. And then Jake?
It's complete.
Almost. So we return it. Where does it return to?
Add 5,
Mhm.
2.
Yeah. So now our add 5 is whatever that function returns, which is add to num1, right? So now this is a function. And then Tanner?
Then we're passing 5, or we're passing 5 in to the number?
Well, we just did that
Yeah,
one, so we skip past that.
Okay. And then we add 2 to 5.
Mm-hmm. So we are calling the add 5 function
Twice.
with the argument 2.
Okay.
No, we only called it once. We called it here. This is a different one. This is add. Now this one's add 5. Add 5, remember, is going to be this function here, because that's what we returned.
Okay.
And then we pass it 2. And then where does it go, Phil?
Well, because add 5 contains that function, it also contains the variable num1 from the original scope,
Mm-hmm.
which is 5.
Mm-hmm. So we hop back up here,
runs
right?
the return statement and it adds 2 to 5.
Yep, exactly. So we call add 5 with 2. We jump up here to the function body. Num2 is now 2. And then we add num1 plus num2. Num1, again, we got from the first time that we called add, right? So num1 equals num. We got 5 from here. And because of closure, we have access to the environment here.
The previous environment.
The previous environment, yes. And that's how we get 7.
So if you had add 5 parentheses 2 again, you get 9. Right?
Well, actually, we add 5 and do 3, it's going to be 8. Why?
Because the add parentheses 5 is retained as num1 equals 5.
Because so, even though we have reference to this scope here, every time we call add 5, we're creating a new scope here. So num2 is going to change. And we're not actually affecting num1. So num1 is being saved. Num1 is always going to be 5 in add 5. But num2 is going to be the one that changes. So when we pass 2 here, num2 is then 2. And when we pass 3, at that point, we make a new scope, this new scope here. But just because we have a new scope for the add to num1 function, that doesn't mean the parent scope is different. It's still the same. And then num2 would be 3, which would be 8.
So what if we didn't have that add to num function? Let's just assume that the whole function definition of add to num1 is gone. I mean, I guess that defeats the purpose of having closure, but but you could still. So then that's just. Then when you assign add parentheses 5 to add 5, you're just. It's like.
It would call this whole thing over again.
Yeah.
And it would reset this variable.
Right. So it'd just be like a regular storing a function in the variable, like your plain vanilla.
Yeah.
Got it.
Yeah. So the key here is that for the closure is that we have a function in here and then we're returning it so that we can call it later.
Right. And then using the parent variable for like permanence or.
Yeah. And actually we don't need this here. This is just for clarification. Like you could actually delete this and call this num. It would actually still work.
So just for fun, if you had, after that last statement, if you had add parentheses 10, and then you,
like where?
I'm sorry, if you had,
Here?
no, at the very bottom. If you said add 5 equals add parentheses 10.
Add 5 equals add 10?
Yes.
And
then you said add 5 parentheses 2, what would you do?
So this would be rewriting add 5. So add 5 was add parentheses 5, right, which is going to be this function. This would overwrite it. Whoops. Whoa. This would overwrite it and make it 10. So then, whoa, okay. Doesn't like it when I click there. So if we did add 5, 2, then that would be 12. Because we're just, whenever we use the assignment like this, it's going to completely override and just delete it.
Whatever was there.
Whatever was there, yeah.
Because it's add 5 keeping that same reference in memory.
No, it will override.
It'll overwrite that, yeah.
Yeah, it'll overwrite everything, yeah. But it would be better if we could just call that add 10, right? But if we did want to do that, it would still be the same.